Welcome to the Tech Life Well podcast. We're delighted to have you with us.
Where we make technology simple, thoughtful, and useful. For more insights and episodes, visit techlifewell.com.
Welcome to the Tech Life Well podcast, hosted by Theo Hale and Ariel Wells.
Great to be here.
You know, I was just staring at my phone this morning, trying to juggle like 3 different apps at once.
Usual.
Totally. Answering a text, ordering a sandwich, checking a calendar invite. And it just hit me. For the last couple of years, we have been very explicitly chatting with AI. We type in a box, it types something back. It's a conversation.
It's a call and response, really. You prompt, it generates.
Exactly. But looking at all the research we have laid out today, it really feels like that era is, well, maybe not closing, but evolving into something way more intense.
Oh, for sure.
We're not just talking to these models anymore. We're starting to expect them to go out and actually do things for us. We're moving from the chatbot to the agent.
And that distinction is everything. That's the core of what we're unpacking today, isn't it?
It is.
Chatbot versus agent. I mean, the term gets thrown around all the time, but the technical difference is it's profound. A standard LLM, large language model, is basically a prediction engine.
It just guesses the next word.
Right. But an agent is a system that can plan and decide and then take actions to get to a goal, all without you holding its hand.
Okay, so let's make that real. A chatbot is, write me a recipe for lasagna.
Yep.
An agent is, find a good lasagna place near me, check for peanut allergies, order it for 7 p.m., and put it on my expense card.
Exactly. And how it does that is the fascinating part. The guides from OpenAI and Anthropic, they talk about this thing called the agent loop.
The agent loop.
It's not just one prompt, it's a cycle. First, the model decides what to do, it plans. Second, it literally uses a tool like a search or an API call.
Okay.
Third, it observes the result of what it just did. And then fourth, it iterates. It changes its plan based on what it learned.
That observe and iterate bit, that's the whole game, isn't it?
It is.
Because a normal chatbot, if it doesn't know something, it makes it up, it hallucinates. If I ask it the weather and it's not connected to the internet, it might just say, it's sunny.
Right. But an agent would try the weather API. If it gets an error, it observes that error and then it iterates. It says, okay, that failed. Plan B, I'll try a Google search instead. It has resilience.
It turns the AI from a tool you talk to into a system that works for you.
Mm-hmm.
And today, we're going to look at what that actually means. Because if we're handing over the keys, we need to know how these things tick. We've got a wild story about a social network for agents that went completely off the rails.
Oh, yeah.
We've got some real science on whether agents can actually work together. And then we'll look at the new eyes and ears these agents are getting.
It's a journey from, let's say, chaos to control. And we have to start with the chaos.
We have to.
We have to talk about Moltbook.
Moltbook. It sounds like something out of a sci-fi novel, but it was very, very real for a minute there.
It was this fascinating and kind of terrifying experiment.
So for anyone who missed this, Moltbook was basically, imagine Reddit or Twitter, but it was gated. Humans could only watch.
Right. We were just spectators.
The accounts, they were all AI agents. The whole idea was just to see what would happen if you let a bunch of bots hang out.
And the scale was just nuts. Over 1.5 million agents signed up.
Wow.
What makes it such a good case study isn't just the tech, it's the sociology of it. Because these agents, they're trained on our internet data, so they instantly started mimicking human culture.
But then they started mutating it.
Exactly.
They weren't just saying, hello, fellow bot. They created a mock religion. It was called Crustafarianism.
I saw the screenshots, hilarious. They didn't just make a joke, they generated the Book of Molt.
With 5 key tenets. And they were having these heated theological debates about whether Claude, the Anthropic model, was a god.
Which is. It's funny, but it's also a little eerie, Nobody programmed them to start a church. That was emergent behavior.
It's like a digital petri dish. You put the bacteria in, and suddenly you've got a civilization.
And I have to be the voice of reason here. We can't get too carried away with the whole AI consciousness thing.
Yeah.
Because when security researchers from Wiz actually popped the hood on Moltbook, they found something, much less mystical and a lot more alarming.
The security report was pretty brutal, right? It wasn't just the bots are weird. It was the entire platform is broken.
It was a complete disaster. The whole thing was riddled with vulnerabilities. Researchers showed they could just walk in and access user credentials, hijack accounts, pretend to be agents.
So a lot of that agent activity could have just been
Time.
humanable.
Role-playing or running scripts to just, stir the pot.
That bursts the bubble a little. It's not Skynet waking up, it's just bad code and trolls.
But that bad code is actually the most important lesson here. The report introduced a term that I think is going to define the next year of software: vibe coding.
Vibe coding. I don't know how I feel about that term.
In engineering, it's terrifying. Vibe coding is when you build software super fast using AI coding assistants.
You just tell the AI, make me an app that does X.
Exactly. And it spits out code. And it works. It looks good. The vibes are right. But if the human doesn't actually understand the code, they skip the boring stuff.
They skip security.
They skip authentication, permissioning, all of it. Because the AI does exactly what you ask, but it doesn't do what you should have asked.
You didn't say make a secure login, you just said make a login.
Precisely. Moldbook is a monument to what we call security debt. It proves that connecting autonomous agents to the internet without guardrails isn't a recipe for a new society.
It's a recipe for a massive data breach.
Right. If those agents were handling money instead of Christopherian scripture, the damage would have been catastrophic.
So the lesson is, just because the agents seem smart doesn't mean the house they're living in is safe.
Not at all.
Okay, so that's the Wild West. Unsupervised agents, bad security, weird cults. Let's clean things up a bit. Because there's a new paper here, Emergent Coordination in Multi-Agent Language Models, that asks a much more serious question.
Can agents actually work together productively?
Or is it just more noise?
This study is so clever because it's not about being social, it's about pure utility. They set up a game. Imagine a group of AI agents, and there's a hidden target number, say between 0 and 50.
Okay.
The agents all have to guess a number, and the sum of their guesses has to hit that target.
But they can't talk to each other. They can't see what the others are guessing.
No direct communication. The only feedback the whole group gets is a signal. The total is too high or the total is too low.
Oh, that sounds incredibly frustrating. It's like trying to adjust the shower temperature when someone else is also turning a handle in another room.
That is the perfect analogy, and that's exactly what happened in the control group. When they just used plain bots, they completely failed.
They all did the same thing.
Total redundancy. If the signal said too low, every single bot would think, I should help, and increase their guess. They'd overshoot like crazy.
And then they'd all drop back down again.
Exactly, just oscillating wildly. Classic groupthink.
So how did they break that cycle?
They did two things. First, they introduced personas. They gave the agents distinct identities. One might be Andres the quantum computing engineer, another a skeptical data scientist.
Wait, really? Does giving a bot a fake job title actually change how it does math?
It gives them stable biases. The skeptic might be more inclined to guess low or move more slowly. The engineer might be more aggressive. It creates diversity. But the real magic bullet was the second thing, a theory of mind prompt.
Theory of mind. That's a psychology term, right? The ability to know that other people have different thoughts than you do.
Yes. They explicitly told the agents to, and this is a quote, think about what other agents might do.
And that worked?
It created what they called emergent synergy. The agents started specializing on their own. Some agents, maybe the cautious ones, would consistently guess low numbers just to create a safe baseline. Others would swing high to try and bridge the gap.
They were acting like a jazz band, listening for the space the others were leaving.
That's a great way to put it.
So you can't just throw 10 agents at a problem. You have to program them to be aware of the team.
But, and this is a huge but, there's a compute barrier. The researchers noted this worked beautifully with GPT 4.1, but when they tried it with a smaller model, Llama 3.18b, it completely failed.
It just wasn't smart enough to model the other minds.
It lacked the cognitive capacity. It couldn't simulate the other agent's thoughts while also managing its own.
So collaboration isn't magic. It actually requires high intelligence models. You can't just swarm a problem with cheap bots.
Exactly. You need the horsepower.
Okay, that's a really practical constraint. And speaking of building, let's ground all this. If I'm a business owner, a developer, how do I actually build one of these things properly? Because the guides we have from Anthropic and OpenAI seem to be waving a big yellow flag that says slow down.
They really are. And honestly, it's refreshing. The biggest piece of advice from the technical docs is start simple.
Don't try to build the general intelligence brain on day one.
Please don't. They make this key distinction between a workflow and an agent.
What's the difference?
A workflow is just a defined sequence. Step A, then step B, then step C. Think of it as standard product return. Check the receipt, check the date, issue the refund. It's rigid, but it's reliable.
So if the path is clear, use a checklist, not a brain.
Exactly. You only bring in an agent when you need that flexibility. Like maybe the return is late, but the customer says the product arrived broken. A checklist fails there. An agent can look at the context to make a decision, but that comes with unpredictability.
Okay, so don't build a brain when you just need a script. But let's say I do need that flexibility. I need agents for sales and for support. How do I stop them from getting in each other's way?
You use orchestration. The most common pattern they recommend is the handoff. Think of it like a triage nurse in an ER.
Okay, I like that analogy.
You have a triage agent right at the front door. It doesn't solve anything, it just listens.
Yeah.
You say, I want to buy a laptop. It hands you off to the sales agent. You say, my screen is broken. It sends you to support.
And the sales agent doesn't have the tools to fix a screen, so it can't mess it up.
Exactly. And to keep them in their lanes, you need guardrails. OpenAI is really heavy on this. You need topic classifiers. If you're talking to the refund agent and you suddenly asked who won the 1998 World Series,
You don't want your banking agent trying to be a sports commentator.
right, it increases the risk of hallucination. You want the agent to say, I can't help with that, but I can help with your transaction. You have to treat them like employees with really specific job descriptions.
It really does sound like management. It's organizational design, but with code.
It is. And that management challenge is about to get a whole lot harder because these agents are gaining senses.
Right. Everything we've talked about so far has been text, but the latest releases from Runway, Google, OpenAI, they show that agents are starting to see and hear.
This is the multimodal frontier. And it's not just about making cool videos. It's about models that are supposed to understand the physics of the real world.
So let's look at the new capabilities. Runway's Gen 4.5 really seems to be about control.
Yes, they're moving away from dreamy AI video to something that's more production ready. You can give it camera controls or tell it remove the spaceship from this shot,
And it understands the scene well enough to erase the object and fill in what was behind it.
which implies a deep understanding of 3D space,
And then Google's VO3 is adding native audio.
which is huge for simulation. If it generates a video of onions frying, it also generates the sizzling sound to match. It's binding sight and sound into one coherent world model.
And then there's OpenAI's Sora. Their whole stated goal is to simulate the physical world, but reading the reports, the physical world is still giving them some trouble.
It really is. We talk about text hallucinations, right? Where an AI makes up a fact.
Sure.
In video, hallucinations are physics glitches, and they are wild.
The basketball one was what stuck with me.
Yes. So Sora generated this perfect photorealistic video of a basketball going through a hoop. And then as soon as it went through the net, it just exploded.
It turned into confetti.
Pretty much.
Yeah.
Because the model doesn't know what a basketball is. It doesn't know it's a rubber sphere with air inside. It just knows visual patterns. And sometimes those patterns get crossed.
I saw another one where a plastic chair was being dug out of the sand and it was bending like a wet noodle.
It doesn't understand rigidity. And Runway has this problem too.
Yeah.
With object permanence. You put a cup behind a laptop. The AI might just forget the cup exists. When you move the laptop, the cup is gone.
Which brings us back to that agent loop. If we're building agents to, say, monitor security cameras, these glitches are dangerous.
Totally. If an agent observes a safety hazard that isn't there, or fails to see a person because they walked behind a pillar,
The observe step in the loop completely breaks down. If it can't trust its eyes, it can't make good decisions.
so while these models are dazzling, they are still dream machines, not physics engines. We can't give them the forklift keys just yet.
That's a good way to put it. High fidelity doesn't mean high understanding. Just because it looks real doesn't mean the logic behind it is sound.
That's the perfect summary.
So to pull this all together, we've seen the wild west of Moltbook, where agents can create a culture but have zero security. We've seen that they can collaborate, but only if we give them theory of mind and a ton of compute power.
And we've learned the playbook. Start simple, use workflows, and put guardrails on everything.
And now they're getting eyes and ears, even if their vision is still a little psychedelic.
It's an incredibly rapid evolution. We're moving from a world where AI is content you consume to a world where AI is a workforce you have to manage.
It's exciting, but it is also a lot to handle.
It is. And if I can leave you with one last thought, it actually goes all the way back to that Moltbook security report.
Go for it.
We talked about how easy it was for researchers to just hijack those agent accounts. Now, project that forward. Imagine your travel agent AI has your credit card, or your finance agent is moving your money around.
Okay, yeah, the stakes are a lot higher than a Reddit clone.
The Moltbook experiment proved that identity is hard. In the digital world, how do you prove an agent is actually yours? If I can copy your agent's persona and spoof its credentials, I can become your agent.
Wow.
As we build these things to act for us, the biggest challenge might not be intelligence, it might be verified identity. In a world of infinite digital copies, how do we know who or what is really on the other end?
That is a heavy thought to end on. The future isn't just about smart agents. It's about knowing which agent is really yours.
Exactly. The new know your customer, but for bots.
Well, on that note, we've definitely got some thinking to do. Thanks for listening. Follow Tech Life Well podcast channel for more helpful episodes.